Hello guys, welcome back to learning microcontrollers. In this video I am going to show you how to make a range finding system using a PIC16F877A microcontroller. So let's get started. This is our PIC16F877A DIL version having 40 pins. This is our IR receiver LED we are going to use in this project, and this is our IR transmitter LED. To interface these LEDs with a PIC, we will need a 10 kilo ohm resistor for the IR receiver and 330 ohm resistor for IR transmitter LED. Let me show you how to do the connections. You name one pin of the IR receiver as in, other pin as the ground. You can shuffle these two pins as you like, doesn't matter. You connect in pin directly with the VCC pin of the PIC16F877A to give IR LED 5 volt. You take your ADC value from the ground pin. You can use any available ADC pin. I am using pin number A0, that is pin number 2 of the PIC16F877A microcontroller. Then the same ground pin will go to one end of the 10 kilo ohm resistor. From the other end of the 10 kilo ohm resistor, you send it to the common ground, that is the ground of the PIC. Now to connect the transmitter LED, you name the larger pin as a 5 volt or the power pin, smaller pin as the ground pin. You cannot shuffle these two pins as you like. It is like a normal LED. You connect ground directly with the ground, that is the smaller pin, and the larger pin will go one end to the one end of the 330 ohm resistor. Another end will go to the common 5 volt supply. In this way our IR receiver and transmitter LEDs are connected. Now to display the output and also for the purpose of calibration, I am going to use the 16:1 LCD. This LCD has no backlight. To interface it with the PIC, we need a 3-pin potentiometer. A 10 kilo ohm will do fine. It has 3 pins, 1, 2, 3 as mentioned on its body. And LCD has 16 pins. If you hold it like this from left to right, it's 1 to 16. Now to do the connections, pin number 1 and 5 of the LCD will go to the common ground. From the same common, you take a wire and you connect it to the one end of the 10 kilo ohm variable resistor. Now the 3 pin of the potentiometer will go to pin number 2 of the LCD, and then you send it to the common 5 volt supply. In this way, potentiometer gets the 5 volt and LCD gets the 5 volt. Now the center pin of the potentiometer is the adjustable pin. This will adjust the contrast, and you connect it to the pin number 3 of the LCD. Now pin number 4 is the RS pin. You can use any available digital input output pin of the PIC16F877A microcontroller for this. I am using pin number C0. For enable, I am using C1. For D4, data pin 4 of the LCD, that is pin 11, I am using C2. For data pin 5, I am using C3. For D6, I am using D0, that is pin number 19. And for data pin 7, I am using pin number 20 of the PIC16, that is pin number D1. So in this way our LCD is connected. Rest of these pins on the LCD 7, 8, 9, 10, 15, 16 will go empty. 15 and 16 are for LCD backlight, and this LCD has no backlight. 7, 8, 9, 10 are for 8-bit mode, while we are using only 4-bit mode. Now what this project is gonna do is that this is our PIC, this is IR transmitter, this is IR receiver, this is our LCD. As soon as the start button of this project is turned on, you power up this project, IR transmitter will fire its IR ray, or it will propagate its ray, and IR receiver will receive data as soon as it starts, because they both are connected to the power. And this receiver will receive the value and it will send the ADC values to the PIC, and PIC will process them using our programming and will display it on the screen. We are making a rangefinder system from 1 to 30 centimeter. It will have steps like 1 to 5 centimeter, 5 to 10, 10 to 15, 15 to 20, 20 to 25, and 25 to 30 centimeter. So whenever an object is placed in this range, it will tell that object is at what distance. So like an object is at this distance, it will say it's plus 30 centimeter. It's out of range. It will not show out of range. It will say plus 30 centimeter. When we move it closer, it will say like 10 to 15. It is in between 10 to 15 centimeter. We move it further close, it's like in between 1 to 5 centimeter. So let's do our programming. Okay guys, this is our micro C for PIC. I zoom it in, go to file, new project. You click on next. You write the name of the project, infrared range finder learning micro. This is the name of our project. I am using PIC16F877A, and the crystal I am using is 20 megahertz. Click on next, and finish. First of all, we need to initialize our LCD. For that, go to library manager. There you have this command LCD. In that you have LCD INIT. In the example below, you have an example of how to initialize an LCD using 4-bit mode. You copy it, you paste it above void main here. Here you can see RS is initialized by using a pin called B4 while we are using C0 as shown in the presentation. For enable we are using C1. For data pin 7 I am using D1. For D6 D0. Then for D5 we are using C3, and for D4 we are using C2. In this way our pin out is corrected and initialized. Now for the pin direction, do exactly same. For RS we are using C0, C1 for EN, D1 for D7, D0 for D6, C3 for D5 and C2 for D4. In this way our pin and directions both are initialized. Now we initialize LCD. Write LCD INIT, this command, you give initialization delay 500 milliseconds, that is 0.5 second will do fine. Now we are also using an ADC pin for the sensor. Initialize all the ADC pins of the PIC16F877A using this command, give initialization delay. Okay, in this way our ADC pins are initialized. Now we go to our forever loop because we have no other sensor or module. Okay, it starts here and ends here. First of all, we need to receive value from the sensor. For that we will need a variable which will store the value. We write integer IR value. So what is our IRV is equal to ADC read from which channel? Channel 0. This will give some initialization delay. 150 will do fine. Okay, what is happening here, that IRV is the integer, it will receive the value. ADC read is the command which will be used to receive value from the sensor using PIC's ADC pins, and A0 is the channel. I am using pin number A0, so I wrote channel 0. If you are using A1 you write 1, A2 for 2 you write 8, like 0, 1, 2. For A3 you write 3. So I am using channel number 0, that is pin number A0. So if you use a different ADC pin, you simply need to change this, rest will remain the same. Now to display this value on the LCD we need a char, because LCD cannot display integers directly. We write IRV1, another variable 5. So we initialized a char array, that is an array which can hold 6 letters, and this array of char is called a string. So we have our string which can display value on the screen. So we do our int to str, write this command int to str. This will convert IRV to IRV1. So whatever is in IRV, that is integer, will be converted into this string, that is IRV1. Give some initialization delay. Okay, before we display our value on the LCD, we first of all remove the cursor. You can keep the cursor if you want, but it looks odd. So I am gonna remove it. Let me show you how. You go to LCD CMD. There you have this LCD CMD command. You copy it, paste it below the LCD initialization command. Then you go back again to LCD CMD. Here you have this table, available LCD commands. In that you search for turn off cursor, this command. You copy this only, and you place it inside the bracket here. Okay, now you give some initialization delay. This will turn off the cursor. Now the next thing is we need to display the value on the screen. For that you write LCD out, start writing from first row, first column. What it should write? It should write whatever is in the string for the purpose of calibration. This code will do for the purpose of calibration, and then we will write our main scale code after we get our values for calibration. Okay, you give for how long the value should be displayed, give it 200 millisecond. For 200 millisecond it will keep on displaying the value, but after the values are displayed, it should clear the LCD for new values. For that you go back again, LCD CMD, there you have LCD CMD clear. You copy it, you place it here. Okay, this will clear the screen, give some initialization delay, 50 will do fine. In this way our code for the purpose of calibration is complete. Now we build it, see if there are any errors. Click on this. Okay, the code is built without any errors. Let me introduce you to our hardware. Okay, this is our hardware. As you can see, let me turn off the previous code. Okay, the previous code is off. This is our IR. As you can see, Okay guys, video was not working. I had adjusted the camera again. So first of all, I removed the previous code. Okay, now this is our IR transmitter, this is our IR receiver, this is our PIC 3.5, this is PIC16F877A at the back, and this is our scale. I will remove this after we have done the calibration. For the calibration purpose, we will need this scale. This is maximum is 1 to 30 centimeter, and above 30 centimeter it should display plus 30 centimeter. Now this is our 16 into 1 LCD with no backlight. This is our variable resistor. So let's burn the code we just wrote. Let me check the code's name. That is infrared rangefinder. So we burn the code, go to file, import hex file, infrared rangefinder, click on write. Okay, you can see the code is being written. So let it write. So once the code is written, then I will give 5 volt from the same PIC 3.5. So the code is written. Let's turn it on. Let's see what happens. Right now, as you can see, there is no target, so it is giving 17 value. Like it's 17 value. So first of all, we check what we get value at 5 centimeter. So I placed an object at 5. Okay, I placed an object at 5 centimeter like this. So value we are receiving is like 780, 704. Okay, at 5 it's like 800, 780, 90, so 660. So we bend it a bit, like at 90 degree it's like above 815 or 820. So we take it like above 800. So we go to our programming, go back, let's zoom it in. So after IRV we got our first calibration value. If IRV is greater than 810, I take 810 because it's like 800 or something, or 800 will be better. 800. If IRV is greater than 800, then what we get is that LCD should display output. Okay, only LCD out. That is, it should display greater than 1 to 5 centimeter. That the object being detected is in between 1 to 5 centimeter. So it's 1, 2, 3, 4, 5, 6, 7, 8. Okay, you make it empty, so so there cannot be any random values on the screen. Our LCD has 8 columns in first row, so we cover all the 8 columns because we are going to use the overwrite, not clear screen method. So let's get our second value. That will be for 5 to 10 centimeter. For that, go back. Now again you take your obstacle and you place it at 10 centimeter. Okay, this is 10 centimeter. Okay, it's like above 300 at 10. Okay, 304. I bring it to, okay, like it's above 300 at 10 centimeter. So our second calibration value, zoom it in, go back to programming. After that you copy paste this loop, write down, add else. If above is not certified, then if IRV is greater than 300, and now we are using comparison, and IRV is less than 800, in between, close the brackets, 1 here and overall 1 here. Okay, now if the value is in between 300 to 800, it means it is 5 to 10 centimeter, like this. 1, 2, 3, 4, 5, 6, 7, 8. You remove this, we only need 8 digits. Leave no digit empty. You give either a space or write something to avoid random values. Now we do for the 10 and 15 centimeter, 10 to 15 centimeter. For that you go back. Okay, I place an obstacle. I place it at 15 centimeter. See what happens, what we get at 15. Oh, this is a 15 centimeter. Oh, sorry. Adjust the scale. Okay, it's done. At 15 centimeter, it's 140, 150, or I do some bending. Okay, I do it again, check it again at 15. Okay, so we can say it's above 140 or 150, but I use 140, so it's above 140. Go back to programming. So you copy paste this, first zoom it in, you copy paste this. Okay, when it is above 140 and less than 300, it means the object is at 10 to 15 centimeter, in between 10 to 15 centimeter. Again count the digits, 1 2 3 4 5 6 7 8. Okay, delete this. So we got first row and it has 8 columns, all 8 are covered. Now there will be no random values on the screen, which we do not want. Now we go for 15 to 20 centimeter. For that you go back, you place an object at 20 centimeters like this. See what value we get. So we are getting like 87, 86, 84. So when I bring it to exact, okay, so we can say it's above 80. So we can say it's above 80. So go back to programming, again zoom it in, copy this. So if IR value is above 80 and less than 140, it means it is in between 15 to 20 centimeter. Now we go for our next value, zoom out. Okay, our next value is at 25 centimeter. So we place an obstacle at 25 centimeter. Let's see what happens. So at 25 we are receiving like 65, 66. So it's like we take it 63. Like if it is above 63, then we write again, we take next value for 25 centimeter. If it is above 63 and less than 80, then it is in between 20 to 25 centimeter like this. Now our final reading, that will be from 25 to 30 centimeter. For that we go back. I had copy pasted first, now I go back. Okay, we place an obstacle at 30 centimeter here. So at 30 we are getting a value 47. So 44, when we tilt it a lot, so we got our value. We take 46. So we write, if it is above 46 and less than 63, then it is in between 25 to 30 centimeter. So that's last value. Now if the value is below, for that you go to the first one, copy this, go back, paste it below, add else if it is less than, you can say 40, or you can write 46, then it is plus 30 centimeter, like it's out of our range. Centimeter 1 2 3 4 5 6 7 8. Okay, that's great. Now since we had done with the calibration and we no longer need to display these random value on the screen, like we are getting this value, we no longer need this value. So we do that, we remove it, we no longer need it. You delete this int to string conversion, you delete this value, and since we had completed all the 8 digits, that the whole row is covered in every value, so there will be no random values. So we can go without clearing the LCD, it will overwrite. So now we check either our code is correct, click on build to see if there are any error. Okay, it's perfectly burned. Now we go back, we change our code, click on write. Okay, the new code is being burned. Let's see what happens. Okay, let it burn. Okay, new code is burned. Now let's see the change. Okay, that's great. It's showing plus 30 centimeter. There is no object in front, so it means it is out of range. There is nothing in front. Now I place an obstacle at 3 centimeters. See, okay, it says in between 1 to 5. That's great. I place it at 8. Okay, it is in between 5 to 10. That's great. Now I place it at 13. Okay, 10 to 15. That's perfect. Now I place it at 17. Okay, 15 to 20. That's perfect. I place it at 22. Okay, that's perfect. I place it at 28. Okay, that's perfect. Now I place it plus 30. That's great. So in short, guys, as you can see, I move forward. It's telling that obstacle is going away. Okay, now I bring it close. Okay, it's at 25, 20, 20, 15 to 20, 10 to 15. This project has great application usually in elevator doors or in projects where you are measuring distances, like in controlling the spindles of motors or XYZ axis movement for safety stops, etc. It's a great project and is a great tool to be used in many projects. I again do this. I place it at randomly like 18. Okay, perfect. It says it's at 15 to 20 centimeter. Now since the calibration is done, we can remove our scale. We no longer need it. Now I place an object here. Okay, it says it is at 25 to 30 centimeters. See, we no longer need the scale. Our scale is now digital, wireless. See, it's 10 to 15 centimeter. I place it here. Okay, it says it is in between 1 to 5 centimeter. I move it back and back 10 to 15. It says it's at 10 to 15 centimeter, and I place it over here. Okay, it's at 15 to 20 centimeter. Okay, that's great. So guys, this is it. I hope you guys learned something from this video. Thank you very much for your time. If there is any question or queries, you can ask in the comments below. So have a nice day until the next video.